Rate of reaction. Speed of reaction. How to measure the speed of a reaction.
The speed of reaction is the speed by which a product is formed, or the reactants are being utilized.
It is measured in two ways. Measuring time for the reaction to complete. Time is inversely proportional to the speed of reaction.
Hence, for the faster reaction to occur, a shorter time is required.
The measurement of the amount of product produced in the given time.
This can be done by plotting a graph of gas released against time or mass left against time.
Directions to check the rate of reaction through gas released. 1. In a conical flask, react together hydrochloric acid and calcium carbonate. 2. Make sure the flask is closed using a cork. 3. A tube is attached from the flask to the gas syringe.
4. Start the timer when the reaction starts.
5. Note the volume collected after equal intervals of time.
6. When the two products have reacted together, note the time and note the volume of gas collected in the syringe. Plot a graph of time on x-axis per minute and volume of gas collected on the y-axis per cm3. Directions to check the rate of reaction through a change in mass.
1. On an electronic balance, put a conical flask. 2. In the flask, add a piece of marble and acid. 3. Make sure the flask is closed with a cotton ball, so when the gas is released, it moves out of the flask. This helps in preventing pressure that will build up. 4. Start the timer. Note the initial mass. 5. Note mass decreased in equal intervals.
6. Once the reaction is over, note down the mass and time. 7. Plot the graph with time on x-axis per minute, and mass decreased per gram on the y-axis. Factors that affect the rate of reaction. 1. The particle size of the reactant. When a large piece of marble reacts with the acid, the reaction will take more time to complete. However, when small pieces of marble are reacted with the same volume of acid, the reaction time decreases. Hence, it shows that particle size and time are inversely proportional to each other.
Explanation: the collisions of particles cause a reaction.
The larger the surface area, the more chances of a collision. The surface area increases as the size of the particle decrease.
2. The concentration of the reactant. The increase in concentration means more particles are present. Hence, the reaction occurs more rapidly.
This shows that the concentration of the reactant and time is in direct proportion to each other.
3. The pressure of the reactant.
The increase in pressure means when the volume of the container is decreased.
Hence, more chances of a collision. Thus, increasing the rate of reaction.
Therefore, the pressure of the reactant and rate of reaction is in direct proportion to each other.
This factor is only for gases. 4. The temperature of reaction. When the temperature increases, the average kinetic energy of the particles increase.
Therefore, a more effective collision occurs between the reactants.
Hence, temperature and rate of reaction are in direct proportion.
Furthermore, the speed of reaction doubles with every 10 degrees Celsius rise in temperature.
5. Catalyst.
Catalysts are the substance that speeds up the rate of the reaction without itself being used at the end of a chemical reaction. Catalysts are usually transition metals such as titanium, nickel, iron, and copper.
They are specific to their reaction. Catalysts work by lowering the activation energy, so bonds are broken down more quickly.
Hence, particles collide more effectively. In other words, the catalyst provides an alternate pathway to the reaction to lower the activation energy. There are a few factors involved that affect the activity of the catalysts.
These include
temperature. Catalysts work best at higher temperatures. The concentration of solutions. Increasing concentration increases the speed of catalyzed reactions. The pressure of the gas. By increasing the pressure, the speed of catalyzed reaction increases.
Different catalysts are used in industries for the following purposes. Reaction, catalyst. Contact process, production of sulfur, vanadium, V, oxide, V2O5. Haber process, production of ammonia, iron, Fe. Cracking of hydrocarbons to produce hydrogen, aluminum oxide, Al2O3 silicon dioxide, SiO2. Production of margarine, nickel. Catalytic converter, converting CO to CO2, titanium rhodium. Production of plastics, titanium chloride, TCl4. Even in the human body, there are biological catalysts, called enzymes, which increase the rate of reaction of different metabolic reactions. One of them is amylase, and it is used in the digestion of carbohydrates. However, these catalysts are highly specific to their substrate. Furthermore, they work best at an optimum temperature. Most of the enzymes work best at a body temperature of 40 degrees Celsius. By decreasing the temperature, they become inactive, and by increasing the temperature, they lose their shape or become denatured. In both cases, enzymes are not able to do their activity. Moreover, just like temperature, enzymes are pH sensitive too. The enzymes are used in industries, too, such as 1. Added in detergents. 2. Used to make the meat tender. 3. Fungal enzymes are used to make antibiotics such as penicillin.